Okay, we've seen that subtracting equations and the second subtraction we did, I didn't label, was the second equation minus the third equation. Gives us these two equations, and you see that our variable c has gone away. That's very convenient. Now we only have two equations and two unknowns. And we want to find values of a and b that satisfy these two equations. If we can find those values, then if we put those values of a and b back into any of the first three equations, we'll be able to solve the equation for c. And that solution, that a, b, c that we get, will solve any of these equations. If we plug our values of a, b, and c in to any one of these three equations, it's going to work. So we'll see how that works out. Now, okay, so we have this system. So now, actually, through the magic of colors, let me put a green box around this, and I'm going to proceed to a solution of this system. So I come up here and I'm going to rewrite this. 3a plus 6b equals 8, and a plus 8b equals 8. Now I want to eliminate a or b. Now it was easy to eliminate c in these equations because I just had c in each equation. Okay? What I can do here though is I can multiply, let's say, the second equation by, let's say, negative 3. If I do, then I'll have 3a up here and I'll have negative 3a here. And when I add the two equations, a is going to go away. So I'm going to do this. I'm going to say, okay, I've got 3a plus 6b equals 8, and I multiply by negative 3. I think I said a minute ago, multiply by 3. Okay, so I multiply the second equation by negative 3. I get negative 3a, and I'm going to get what? Negative 3 times 8b, that's going to be negative 24b, and that equals negative 24. So to get from here to here, I multiplied the second equation by negative 3. Now I add my two equations. Okay? I'm going to get, well, 3a and negative 3a gives me 0. 6b minus 24b is negative 18b. 8 minus 24 is negative 16. And now I can solve for b. Negative 16 over negative 18. I'm going to write a negative there. Okay? Which is, what? 8/9. Now that I have b, I can substitute this 8/9 in for b in either this equation or this one and solve it for a. So let's do that. Now I'm going to get colorful on you again. Not everybody agrees with the use of color, but many students seem to find it an advantage. Okay, so what I'm going to do is I'm going to take b equals 8/9, and I'm going to plug that into this equation, and I just picked this one because 6 divided by 9 reduces better than 24 divided by 9. It's actually not that much different. But I take this, put it into this equation, which gives me what? 3a plus 6 multiplied by 8/9 equals 8. Okay, now I can reduce this. It's not absolutely necessary to do so, but 6 over 9 becomes 2 over 3, and then the 2 times the 8 is 16, so I would have 16/3. That equals 8. Now at this stage I could choose to do one of two things. I could find common denominators and all that, subtract the 16/3 from the 8, and it wouldn't be too difficult to do that. I'd have 24/3 minus 16/3 to give me 8/3. Excuse me. And then I have to divide that by 3 and all that stuff. I'm going to instead clear my denominators, which is almost always a good thing to do. I'm going to multiply both sides by 3. And I'll actually write the steps out. I got 3 times 3a plus 3 times 16/3 plus 3 times 8, and it's not plus, equals 3 times 8. Okay? And now 3 times 3a is 9a. 3 divided by 3 is 1 times 16 is 16. I don't cross those out. I don't even talk about cancellation because people do it so poorly. It's not taught well, it's not understood well. Okay, anyhow, 9a plus 16 equals 24. Well, it's obvious. I'm going to subtract 16 from 24. I'm going to get 8. 9a is 8, so a equals 8/9. So a is 8/9 and b is 8/9. If I've done this right. That looks a little suspicious to me. Remember, we've always got to debug things, and I'm not trying to hide any errors I make. Let's zoom back a little bit so we can see this, okay? So, now we know that a equals 8/9. Now what can we do with that? Well, let's find another color here. We can take the value of b and the value of a and plug it in to any one of these equations. We'd have value for a and a value for b. We could solve for c. So let's go ahead and do that. Let's use the third equation. Doesn't really matter which, but you have the smallest numbers of the third equation, so we'll do that. Okay, so just to a is 8/9, b is 8/9. A minus 3b plus c is 0. So 8/9 minus 3 times 8/9 plus c equals 0. I'm going to clear my denominators. I'm going to multiply through by 9. I'm not going to write out all the steps this time. I'm going to get 8 minus 24 plus 9c equals 0, so that c is going to turn out to be, well, 8 minus 24 is negative 16. Add that to both sides. I have 16. Divide both sides by 9. I get 16 over 9. So now I've concluded that a, b, and c have the values you see here. If I then plug a, b, and c back into any of these equations, it should work out. Now, I don't want to plug into this equation because I used this equation directly to evaluate c. So if my a and b values were wrong, this equation wouldn't catch the error, as long as I solved correctly for c with my wrong a and b values. So I want to use one of the first two equations. Now, we might be running a little close. No, we're good. We're good. Okay? So I want to check. I'm running out of room here, and unfortunately I often do that. And I'm going to leave myself a little window here to check it in. Okay, so 4a plus 3b plus c equals 0. If my values of a, b, and c are correct, if I substitute for a, b, and c, it's going to work out. It's not equal to 0, it's equal to 8. Okay, so I have 4 times 8/9 plus 3 times 8/9 plus 16/9 should equal 8. Well, I could clear my denominators, you know, all the 9s would go away, and 8 times 9 would be 72 and everything. should then add up. But since I have the same denominator on every one of these, 4 times 8/9 would be 32/9. 3 times 8 is 56. So that would be 56. Where am I getting 56? I don't even know where that number came from. Anyhow, it's 24. I know I added the 32 and the 24 because I was looking ahead, and I wrote down the 56. So 16 over 9 should equal 8. Well, 32 and 24 is 56, and 56 and 16 is 72 over 9 equals 8, and that's true if we understand our division by single-digit numbers and so forth. 9 times 8 is 72. So it worked. Okay, well that is an illustration of the process. Now with 3 equations and 3 unknowns, it isn't always going to happen that C is the same, or that one of these variables is the same in all 3 equations. So you might have to do a little more work to eliminate one of the variables to get a set of 2 equations. After that, everything goes much like what you see.